Another thing that we are starting with this model, we are assuming in this model, is that labor is also growing. So we assume that labor grows at the rate of n, right? तो यहां पर हमने ऐसा कुछ इक्वेशन लिख दिया that so basically this is how we write the equations in maths. जब हम differential लिखते हैं, this is one way of starting off with it. तो हमने यहाँ किया ना, we are saying that how labor changes over time, it is equal to some constant value of the labor into, this is e to the power nt. Now suppose I take log on both sides. So log lt will be log L naught e to the power nt. Achha, remember that I am taking log with e as the base, exponent as the base. तो अगर आपको चाहिए ना, so instead of log to the base e, you can also write this as ln. It means the same thing. My base is exponent. ठीक है? Now just try to go ahead and try to open this up. इसको खोलने का कोशिश करो. So what we will get, log m n is log m plus log n. So here I will go ahead and get ln lt is equal to ln L naught plus ln e to the power nt. So ln lt is equal to ln L naught, power will come down, nt ln e. log का जब बेस भी e है और निकालना भी log e का है, that gives the value 1. So this part will turn out to be 1 in our case. So we will go ahead and we will get ln lt is equal to ln L naught plus nt into 1. And this will go ahead and this will give me ln lt equal to ln L naught plus n into t. Now I can just differentiate this with respect to time. So 1 by t dlt by dt equal to, this is a constant, its differentiation will be 0 and differentiation of time will be 1. So this will give me 1 by lt into lt का dot, how L is changing over time, और ये है lt log का differentiation करके, this will be equal to n. So this will give me how log changes over time by initial value of L equal to n. And this is nothing but this is the growth rate of labor equal to n. तो ये इक्वेशन बेसिकली सिर्फ एक बेसिक चीज को रिप्रेजेंट करती है that whenever you are given this kind of equation, so ये यहाँ पे जो भी वेरिएबल होगा it will be growing at this rate, जो t के साथ कोएफिशिएंट होगा at that rate. और उसी चीज को हमने यहाँ पर प्रूव किया है that अगर मैं लेबर का ग्रोथ रेट निकालूं, that will come out as n. Labor is growing at the rate n. ठीक है? Okay. So this is what we have here. Now, let us go ahead and let us try to combine certain things together now. So what I am going ahead and doing is I am starting with this equation. This equation, यहां देखो, यहां पर हमने k, small k को लिखा था capital K by L. You remember? Small k was capital K by L. This is nothing. Capital per unit of labor is capital K by L. ये लिखा था. अब when we tried solving this thing, right? Then I got this equation from her. इसी को थोड़ा सा हमने log लेकर जब सॉल्व किया तो यहां पर ये इक्वेशन आया. So I am picking upon this equation. Pick this equation. I am picking upon this equation. तो जब मैंने इस equation को pick up किया, I start with this equation. This is coming from above. Okay. Then you remember that I had my capital accumulation equation और उसमें हमने क्या लिखा था? that change in capital, not capital per worker, change in capital. Capital कैसे change हो रहा था? Due to investment it was increasing, due to depreciation it was decreasing. तो इस k dot की जगह पे I can go ahead and plug in this, right? So instead of this k dot I have just plugged in this value. यहाँ पर अभी भी बाकी सब same है. Now I am going to just open this up. तो ये हो जाएगा s y by k minus delta k by k. y by k is small y. ठीक है, output per unit of not y by k is small y. I will keep this as y by k only for now. And this is going to be minus delta k by k. ठीक है. Now what I am going to go ahead and I am going to do is that here instead of change in labor upon labor, I am going to go ahead and I am going to replace this with n. This is the growth rate of labor. Okay. So what I will be getting here is that k dot by k. इस चीज को मैंने open up किया. I got s y by k minus ये वाला part हो गया delta minus growth rate of labor is n. Okay. Now, what I am going to go ahead and do is I am going to do a little more change. So here I am going to divide by labor both in numerator and denominator. So this will become S. This is output per unit labor. This will become small y. This is capital per unit labor. ये हो जाएगा small k minus delta plus n. I have taken negative sign common. ये हो जाएगा k dot by k. So my k dot will become s. ये वाला चीज multiply कर दो on the two sides. So you will get small y minus delta plus n small k. This is your equation in terms of capital per unit labor and output per unit labor. तो हमारा equation क्या आ गया? What is the equation we have got? We have got that the change in capital per unit worker, this is going to be savings rate into output per unit worker into a minus depreciation plus the rate of change of the labor into the capital per unit worker. Everything is in small k's and small y's now. जो initial capital accumulation equation था, that was in capital K and capital Y. But जो अब वाला equation है, that is in small k's and small y's. अब ध्यान से देखो what we are saying in this equation. This part is telling me that when my savings will increase, then my investment will increase, then my capital per unit labor will increase. ये वाला part ये बता रहा है. It will increase this thing. There is a negative sign here. So negative sign means decreasing capital per unit worker. So we are saying that the capital per unit worker can decrease due to two reasons. दो reasons से वो कम हो सकता है. The first reason can be depreciation. Whenever there is going to be wear and tear of capital, जब भी depreciation होगा, then it is going to decrease your capital per unit worker. Capital कम हो जाएगा तो capital per unit worker भी कम हो जाएगा. The second thing why it can decrease is due to the population growth. Due to population growth. So what this goes ahead and this says is that when population will grow, जब population बढ़ेगी, it means that there will be more labor. So जो भी हमारा capital होगा, whatever will be our machines, it needs to be distributed among more number of people. You see this? Small k was k by L. So when labor is increasing, then the same capital needs to be distributed among more people. So capital per unit worker will decrease. हर इंसान को जो मिलेगा वो कम हो जाएगा. So imagine land. When there were 5 people for 1 acre of land, everyone was getting 1/5 acre of land. But now when people increase to 10, so everyone will get 1/10 acre of land. So everyone will get less land when the number of people increase. So there are two reasons why capital per unit worker will decrease. So these are decreasing this and this is increasing it. Okay. If there were no new investment and no depreciation, capital per worker would decline because of increase in labor force. तो अगर कोई नई इन्वेस्टमेंट हम नहीं करते, this is zero, no new investment, and depreciation is also zero, so capital per worker will continuously decline. जिस भी economy में there will be increase in population. Solving a model. If we need to understand how to solve a model, we need to go ahead and we need to consider 3 kind of variables. किसी भी मॉडल को सॉल्व करने के लिए 3 तरीके की चीजें जानना जरूरी है. The first one is called endogenous variables. Endogenous variables are those variables which are determined within the model, जिनको हम मॉडल के अंदर ही determine कर रहे हैं. Like here within the model, I want to determine what is my equilibrium level of capital per worker. What is my equilibrium level of output per worker? So those variables which are determined within the model, they are called as endogenous variables. The second one that we have, that is called as exogenous variable. Exogenous variables are those variables which are determined outside the model, but they change over time. Like for example, we assume that technology is determined outside the model, right? For example, this can change over time, but currently I am not determining. I am not finding the equilibrium level of technology. So it is an outside variable, but it can change over time. Similarly, the number of workers in the economy, the growth of worker is exogenous, but it can change over time. Parameters. Parameters are values which are small constants, जैसे alpha. जब हमने लिखा y is equal to k to the power alpha, alpha is the parameter. When we say that savings is some proportion of the output, so savings rate is the parameter. When we had written L is equal to L naught e to the power nt, ये constant एक parameter है. So parameter are constants and numbers given to us in the model. Whenever we solve any model, our aim is to solve for the endogenous variables. जो variable हमें determine करने हैं, given the exogenous variables and parameters, right? तो exogenous variables और parameters model के बाहर का चीज हैं, उनको constant मानते हुए हमें model के अंदर जो determine कर रहे हैं उसके लिए solve करना है. The Solow diagram. Now we have got an equation of the Solow model. और हमारा equation क्या आया है? K dot is equal to sy minus n plus delta k. I want to solve this diagrammatically. So I define something called as the steady state. What is a steady state? A steady state is that state of capital such that k dot is 0. There is no change in capital per worker. वो capital per worker, वो small k, such that k dot is 0. उसको हम बोल देते हैं steady state level of capital. So if I go ahead and I plug this as 0, I will get 0 is equal to sy minus n plus delta k. And from here I will get sy is equal to n plus delta k. Okay. Now just try to go ahead and understand this part, the left hand side. So if I tell you that I want to plot my production function y is equal to k to the power alpha, तो हमने बोला था that the production function will be concave due to diminishing returns to capital. यहाँ पे मेरा small k है, यहाँ पे y है. Now savings are some proportion of this y. तो if this is y, इसी को ही हमने कुछ s से multiply किया, s is some fraction, तो same diagram will shift a little downwards and give me s times y. S can be 5%, 10%, 15%, 20%. Some proportion of y is s times y. Now look here. N is a constant. Delta is a constant. N plus delta is constant. Constant into k. That means if I ask you, plot, suppose z is equal to some constant. Constant is 5 times k. How will you plot this? Very simple. When k is 1, z will be 5. When k is 2, z will be 10. So it means when k takes some value, then I will get some value. Then when k takes the next value, I will get some value which will increase, but it will be linear function of k. So it means that there is a line that I am drawing, and this line represents n plus delta times k. It's a linear function of k. Now, wherever we go ahead and wherever we see the intersection of these two curves, this curve and this curve, ये वाला curve और ये वाला curve का intersection, that is where k dot will be 0, and that will be called as the steady state level of capital. उसी को हम steady state level of capital बोल देंगे. Okay, so this is what I have drawn here. Done. ठीक है. Now, I want to distinguish between two important terms today. The first term that is called as capital deepening, and the second term is called as capital widening. दो बहुत अलग चीजें हैं. कैपिटल डीपनिंग का मतलब होता है जब के डॉट बढ़ता है, जब के डॉट इंक्रीज होता है. मतलब कैपिटल पर यूनिट वर्कर जब ये बढ़ रहा है, then that is called as capital deepening. So when will k dot increase over time? When will it be positive? When sy minus delta plus nk will be greater than 0. Sy will be greater than n plus delta k. माने in this region, in the diagram that we had plotted, in this region, यहां देखो, in this region ये sy है, ये कर्व sy बताता है. This is n plus delta k. The gap is positive. So sy is greater than n plus delta k. This is called as capital deepening. So capital deepening is when this k dot, small k dot, capital per worker is changing over time. That's capital deepening. Another thing which we can go ahead and we can identify, उसको बोलते हैं capital widening. Capital widening is when k dot is not changing. मतलब ये k dot तो 0 ही है, but capital K, ये वाला K, ये change हो रहा है. मतलब जैसे for example, suppose I tell you that now I have, instead of 5, I have 10 machines. But first, earlier I had 5 people. Now I have 10 people also. So the number of machines have increased. कितनी machine थी वो तो बढ़ी हैं, but जितने लोग थे वो भी बढ़ गए. So per unit capital has remained unchanged. But this number of machines have increased now. Capital K has increased now. So capital K means this big K, right? This has increased, right? So this is called as capital widening. So capital widening is basically when your capital K, बड़ा K जो बना रहे हैं, capital in the economy, that is increasing, but the small k, that is not changing. और capital deepening होता है when the small k is increasing, right? That is capital deepening. ठीक है. Now let's try to analyze two more things. The first one is What happens if there is any economy that starts at a level which is K naught, which is below the steady state? अगर हमने यहाँ कहीं से economy में शुरू किया, so you can see that this is representing investment. That means increase in capital. This is representing declines in capital. The increase in capital, SY is greater than N plus delta K. So SY minus N plus delta K is greater than 0. So K dot is greater than 0. So small k will increase over time. So we will go and increase small k over time till we reach the steady state of capital. So over time, capital will increase. Similarly, if we begin with some capital which is below, which is after steady state, right? So suppose I start here, K naught, this is K star. So you notice that at this K naught, this depreciation part is more. My N plus delta K, this is more than the investment part, S times Y. So SY minus N plus delta K, this is less than 0 if I take this here. So change in capital will be less than 0. That means capital will decline over time till I reach the steady state level of capital. So from both, whether an economy starts before the steady state or whether an economy starts after the steady state, the economy will always reach the steady state. Consumption per worker. We can also define something which is known as consumption per worker, and this can be defined as the difference between output per worker minus savings per worker. Savings were some proportion of the output, so the difference between Y and SY at steady state, this can be called as consumption per worker. So this gap, really, this gap goes ahead and it represents consumption per worker. Now, many times we want to go ahead and we want to maximize the value of this consumption per worker. हमें ये हर वर्कर को कितना कंजम्पशन मिल रहा है, कभी कभी हमारा एम होता है टू मैक्सिमाइज दैट लेवल ऑफ स्टेडी स्टेट कैपिटल, जो स्टेडी स्टेट कैपिटल इस कंजम्पशन पर वर्कर को मैक्सिमाइज करता है, माने इस गैप को मैक्सिमाइज करता है, बट स्टेडी स्टेट होना जरूरी है, दैट लेवल ऑफ स्टेडी स्टेट कैपिटल which maximizes consumption per worker, that is basically called as the golden rule of capital. That becomes the golden rule of capital. Okay. So we'll stop here for today and then we will start with the comparative statics in the next class. Okay, thank you.